Okay, good afternoon, class. At this point, we are busy with trigonometry, trigonometric ratios, chapter 7. I think it's our second last lesson. The last lesson will be dealing with the problems that you had with check your skills exercise, which is due tomorrow. No? Alright, don't forget about that. We'll discuss that exercise tomorrow. But that was chapter 6. 6 is for tomorrow, no? Not 7. 7 is for Monday. Next week, Thursday. Yeah, Monday. Doesn't mean you were absent one day for the week. I'm just going to make it. Huh? So I noticed you were absent. That's why I asked them, where were you? So I'm expecting, you always ask something during the lesson. You do, which is a good thing. People, if you have a problem with, listen, if you feel that I'm doing something that is detrimental to your learning and understanding of the subject, please tell me. Okay? If I'm going too fast, or I'm going too slow, or I'm giving you too much work. Okay? A couple of years ago, there was learners that went to the principal that said I gave them too much work. Okay? So, what I did was I didn't check those learners' work. So what they needed to do was, they needed to take it upon themselves and do whatever they feel they could do for homework. But the rest of the learners still wanted to do well in maths. And they did all the work that I gave them. I don't give you this work to bombard you and to be difficult. I know many times you feel that the maths teacher is the worst teacher on the school. No? That's normal. If I was an L teacher, I would have been the best teacher at the school. I'm serious. All the nice conversations you will have. Times you'll cry and times you'll laugh. I'll show you how to change a tire. Talk about the taxes. Yeah. Listen, LO is life skills. No. Listen, you can do anything in LO. You can. I would have taken you guys, everybody of you would have done your learners. You would have got learners for driving. Yeah, because those are what things that other schools do. I would have been excited. What? No, because this is my passion. Maths is my passion. No. If I'm going to listen to your guys' stories, I'll cry with you. So that is why I don't like listening to your people's stories. Sometimes I hear things and I make as if I don't hear it. Okay. But people, in future, if you have a problem, please tell me. Listen, you're going too fast, so listen, the videos is not working for me, or whatever the problem is, just tell me. Then I will try and sort it out for you. Okay? I try and be very understanding. Not always very understanding. But you come to me later on and you come to me break, you'll always see me break here. Speak to me, then I'll try and sort it out for you. Okay? Because if you guys do well in grade 12, then it looks like I'm doing my job. Yeah. But now it looks like I'm not doing my job because you guys don't want to produce the top results. No? And the class test, you get what you get and things like that. The exams is not as bad, but the class test is most dismal. No? Yeah. So, if you have a problem, please let me know. I will then address it with us, or as a class or whatever, and we'll try and sort it out for you. Okay? As I say, at the end of the day, if you guys do well, then it's a good reflection on us. Okay? Right, here we go. People, exercise 7.30. Any issues here? You have to do everything. No? Any problems with this homework here? Sorry? Nothing. Now it feels like you guys didn't do the homework again. Oh, it's done. Okay.
So,
Yes.
um,
Yes.
how do you know when to say that k times 180? Like, I don't understand that.
It's if the solution is repeated every 180 degrees. Like if you look at this one in particular, no? If you look at the cos graph, and it's where cos of theta is equal to 0. Now where is it 0? Is it 0? This is 0, 1 and minus 1. Where is it 0? At 90 and 270. Not so. So normally we would have said theta is equal to 90 plus k times 360, because of that particular solution repeats itself every 360 degrees. Whereas this one here repeats itself also 360. So here we would have had 90 plus k times 360 or 270 plus k times 360. But if you look at this closely, you'll say, okay, but this solution repeats itself every 180 degrees. So instead of representing it as two branches or two separate solutions, I can just say 90 plus k times 360. 180, sorry. Why? Because that solution is repeating itself every 180 degrees. Did you get a full mark anyway? So if you're not sure when to, then rather not write it like this, but write it full out. Sometimes you will have 3 branches, whereas this could have been written as 1. You'll still get two full marks for it. Okay? Yes. Your marks are the same. I wouldn't tell you, don't forget to write the case in elementary reasons. I forgot to tell you that. I meant to say something, but I forgot now. Okay. Anything else? Yes. What was your question? Oh, number 6. Exercise 7.3, 13, page 251, number 6. Okay, so the question says for which values will this identities be undefined? Not so. So in number 6, where would it be undefined? Is there a tan? That's the first thing I always look for. Is there a tan? No. So it is where cos of beta is equal to -1. Or 1 plus cos beta is equal to 0. So where is cos of beta equal to -1? At 180. Not so. So what do I write here? Beta is equal to 180 plus k times 360. Not so. On the other hand, it is where cos of 1 minus cos of beta is equal to 0. So it is where cos of beta is equal to 1. So where is cos of beta equal to 1? At 0 and at 360. Can you see that? That was a repeated solution. So that I can just write it as beta is equal to 0 plus k times 360. Or we sine squared beta is equal to 0. There's a square root. So we sine beta is equal to 0. We sine 0, there's a sine graph. Sine is 0 at 0, 180, 360. So I can say 0 plus k times 360, which I already accounted for. So do I have to say that one? No. This would be 180 plus k times 360. Don't I have that already? Yes. So do I have to write it? No. Okay, so there you're going to get full 2 marks. Don't forget, k is an element of integer. If you forget this, of course you lose 1 mark. If you write it in, there's no mark for it. Okay, yes?
So, I just put it as one solution.
I'm still getting. Okay. You're not all so sharp like you. You. But of course, as you can see, This solution repeats itself. It's 0, 0. Then was 90 here? Did we consider 90? No. But we considered 180, yes? Then 360. So what do you notice here? That this solution repeats itself every 180 degrees, which comes to our question again. So here you could have written it as beta is equal to, don't have to write a 0, or if you put 0 degrees plus k times every 180 degrees, or beta is equal to k times 180, where k is an element of. Now the textbook will have this answer here, not so, but if you write it both, full 2 marks anyway. Okay. Anything else with that exercise? Yes?
So for sign of, when you say sign of, when you sign of x equals 0, so why don't you just say that the one,
So you're saying sine of x?
sign of x equals 0, sign of x equals 1, or cos of x equals,
So cos of x is equal to 0. Huh?
or cos of x equals 1, right?
Or cos of x equal to 1 or negative 1, yes?
Yeah, and then sin of x equals 0 minus 1.
Sine of x equal to 0 minus 1.
And 1, yeah. So why don't you just say for all of those times 1, because it's always going to repeat, like it's always repeated 1, 8, 1, 8.
It is one case where it's not going to be there. Because if you got the cos graph and cos of x equal to 1, that is not every 180 degrees. That's going to give you 0 plus k times 360. However, yes, that will apply here for 90 and 270. It wouldn't apply for the 180 either. Can you see that? So if it's 1, then it will be, we listed here for you. If it's 1, it's going to be x is equal to 0 plus k times 360. Only. If cos of x, or cos of x is equal to minus 1, is where x is equal to 180 plus k times 360. However, the other one, yes, 90 plus k times 360 or 270 plus k times 360, that can be written as, these two can be written as x is equal to 90 plus k times 1. Okay. Now let's look at the sine graph. Look at the sine graph. So if we look at sine of 1, that is not the case. Can you see that? Sine of 1? That is only at 90. So x is equal to 90 plus k times 360. Only. What if sine of x is equal to minus 1? That's it. 270. Not so. So that is going to be x is equal to 270 plus k times 360. Only. However, again, when it comes to the 0, 180 and the 360, is where sine of x is equal to 0. In that case, we can say x equals 0 plus k times 360, or x equal to 180 plus k times 360, or x is equal to 0 plus k times 360, 180. And that solution is repeated every 180 degrees. So it's not always the case. It depends what your equation is. Of course, we case an element of. Okay, any other problems there? Yes? 7? take this off here. Don't forget about the extra classes. No, your days is on a Thursday, exclusively for grade 11s. No? And if you want, you can come on a Monday and a Tuesday as well to the other teachers as well. No? So make use of the resources you have. People number 7. What can we say here? Is there 10? Yes, so automatically we write 10 of, no, for 10 it's going to be theta is equal to 90 plus k times 180. Right, so that one is done. Then we got 10, 1 plus 10 theta is equal to 0. So tan theta is equal to minus 1, and where's tan theta minus 1? I take it to the graph. Tan theta is minus 1 at negative 45. Not so. Or you could have said is 180 plus 90 plus 45, which is 135. Okay? So I can write this as theta is equal to negative 45. Or 135 plus k times 180. Well, either one of the two. No? Then, this one here, where the denominator is equal to 0. So that's the first one. Second one, third one is where cos of theta is equal to minus sine theta. Cos of a sine of a cos is tan, so tan of theta is equal to negative 1. I've accounted for that already, I don't go further. Okay? If you go to the next one. You see sine theta plus cos theta is the sine of cos theta plus sine theta. Can you see that? So there's my solution. So there's the one, and there's the other. Okay. Anything else? Okay. No problems with 8 and 9? Okay, anything else that's the issue here? No. Alright, so let's go into the other section. So Monday's lesson will be the wrap up of the section of work. Okay. I'll stop the video at this point.